101, February 25th. 5th. I just finished work. This is ridiculous. I don't know. I don't know how to get jump out of this vicious cycle. I have no idea. Something needs to be done. It's just so much work, man. So much work. Maybe I'm saying yes to too many things, but there are things I say yes to because I really want to do it. Because there are things I'm interested in doing. There are also things I have to do that I don't want to do. There are like different buckets, right? There are the things that I must do, regardless if I want to do or not. There are things that it will be nice to do, even though I'm not very fond of, but it'll be nice to do, to build up to build up goodwill. And there are things I'm not supposed to do, but I'm interested in it and I want to do it. So that, yeah. Boy, this is you learn, right? I never really have this in the past. I mean, there were moments in the past. Remember, in my last job, I have something similar. But overall, it's not. I didn't feel as draining as I feel right now. Yeah. Anyway, maximum absolute sum of any subarray. Okay, the absolute sum of a subarray is the absolute value when you add them together. Return the maximum absolute sum of any possible empty subarray. Why would it be empty? Right? Even if it's 0, it's still good. Maximum absolute sum of any subarray. Okay, so what do we have? We have 1, minus 3, 2, 3, and minus 4. Right? Well, let's do, a prefix sum first. So 1, minus 2, 0, 3, minus 1. Right? So from here, we get to know all possible subarray sums. Okay? And we want to find the maximum of them. We want to find the maximum. And then we use 1 to minus another 1, right? So if I have a negative value, then I can use a positive value. There you go. We got a 5. If I get a very large negative value, so if I have a negative and a positive, right, that's one way to get. Or I have a positive and a negative, right? Therefore, what we want to find is for each negative value, I want to know the maximum positive value. So I have a suffix maximum. So I need a suffix max. So in this case, it's going to be minus 1, 3, 3, 3, 3. And for this, I need a prefix min. Right, a suffix max is handled this. And this is so if we find a positive value, then we need a negative value. So which means this is going to be a so we want to find this, we want to find the negative. Or you can say on this side, once we find a positive, we want the minimum negative. right? I want a minimal negative, but I will go through every single negative, so I think it should be fine. So I need a suffix min, right? So it's going -1, -1, -1, -1, -2, and -2, right? I think you get a little bit more, too much. -1, -1, -1. Yeah, this is only one value here. Right, so a suffix min. So therefore, as we go through, when we hit a positive value, we try to find the negative max and minimum negative. So basically here is -2 -1. Ooh wee! We probably should get a 0 here. Right? We should get a 0. Then we'll have, oh, do we get a 0? So when you get a 0, you get the absolute, right? You find the absolute. Oh yeah, it's just these two, right? It's just these two. So when you get a 0, you find this and this. So that could be our starting point. And the starting point is actually by this, which we can get because I can do -1 -3, or when I hit this, then I get -1, then I get -4. So okay, I don't really need this because I can just start with absolute value of 2. So I just start with 3, and then if it's 1, I got 3 -2, so I get 5. So this minus this 0 will be this or this, so like both, right? If it's 0, then it's this or this. So this minus this or this minus this. 3 is going to be this minus this. 4 -1 will be at the end. Nothing, right? Because we already handled it. Yeah, because we are trying to find. So we don't do the last one. Don't do the last one. We just do, because the last one doesn't really count. How do you count the last one? Nobody can minus the last one. Last one is just the sum of everything. And we just say if there's any sub. How about by itself? Well, by itself, it handled in the previous. So yeah, I think the last value you don't really handle. Yeah, we already handled it. The total we handled there as well. Okay. So we'll have to. Now to save space, I think we should do for each positive, because we should get a. So we should get a prefix. We shall get a prefix min and a prefix max, right? So when we hit a 0, ooh, when we hit a 0, that's actually not. Well, we start with all 0. So the first one we'll get it. And then there's nothing in the front. And then we say it's 1, right? That's -2. So prefix max is 1. Prefix min is still 0. So we got -2, so now we got 3 and -2. 1 and -2. That was 0. So it's either. So we do both, right? It's a 0, we do both. We can do both as well. Positive, we can minus the negative, or we minus the positive. It doesn't matter. It does not matter. It's just the thing so far. Okay. Think we have an idea. Oh, better do it fast, because I feel like I'm fading. My capacity is fading fast. So we need to handle this fast. We also have P min and then P max, right? Oh, we also need a res. Why don't you put them together? Right, so we got n, so we say p sum plus equal to n. Now we have a prefix sum. And then res shall equal to std max res. That could be n minus p min. Right, and then we'll do another round. Actually, we'll say n minus p max. And now return res. Use prefix sum, prefix max, and prefix min. And then find the prefix max and prefix min of the prefix sum. Then for each prefix sum, we compute p sum minus p max and p sum minus p min. We take larger of the two and keep track of the max. We take the max of the two. Okay, now let's try. A bunch of test case for us to try. We can also do, 0, which is allowed. What else? We go all positive, or we go all negative. All right, we'll run it. That's not right. It was not right. For one, I think I need to do std abs on this. I don't think it will affect the result, but at least make it. Let's see if it affects. Oh, now we have more wrong. Huh. I wonder why. 7. Oh, it's not n. It's p sum. There you go. That's good. That's good. Let's take a look. Editorial. Prefix sum. On. We did prefix sum. We did the min. We did the max. Yes. And we do this, this, this. Yeah, this one also handle like if it's larger than 0, smaller than 0. I don't handle it. I just put them all in there. I wonder even do I even need to do the ABS? I think I do need the ABS though, because it may be possible that it become a negative. Yeah, so I do need the ABS. I'm pretty sure this one will. There we go. Okay, that's good. Prefix sum shorter. Minimum prefix sum. Maximum prefix sum. That is true, because all you want is the minimum and the maximum, right? Yes, you do just need to find the minimum and find the maximum. Oh, this is good. This is good. So we can have a better solution. And I want a better solution, because a better solution is very easy to do. So definitely give me a more Ghana to just implement it, right? Just to implement it. So this solution is inspired by the editorial. You don't have to compute each subarray sum, each absolute subarray sum along the way. All we need, right, is to find the min and max prefix sum, and their difference is the answer. So I need p sum equals 0, p min is 0, p max is 0, right? Say 4 int n is nums, p sum plus equal to n, p min, p sum, p max, p sum, now return p max minus p min. Okay, we'll try it here. Yep, this is definitely a better solution. Yeah, same runtime, but it's better. We know it's better. Okay, that's it. That's good. Done. I'll see you guys tomorrow. Adios.